Good morning, everybody. I'd like to welcome you to the webinar. This is session 3 of 8 webinar sessions that we are holding this year to help schools and district leaders develop and refine culturally responsive math intervention structures based on research and recommended practice. I'm Sarah Sum, a Technical Assistance Coordinator from the Wisconsin RTI Center, and I'll be facilitating today's session. I'm joined by my colleague Heidi Erstad, who led us in the second session, and will be working behind the scenes today to answer questions in the chat box, technical or otherwise, as they may come up. We'll be joined later by some amazing guest speakers. We'll introduce them when we get to their section of the webinar. This webinar is being recorded and will be made available on the Wisconsin RTI Center website, along with any of the presentations or handouts shared today. We'll share the address of that at the end of the webinar, as well as send it to you via email. We've designed the webinar series with these outcomes in mind. By the end of the series, we want you to know recommended practices for students struggling to learn math. We want you to be able to have access to math intervention research and resources, as well as connect with and hear from practitioners across the state. And ultimately, we'd like you to be able to create a plan to improve your school's math interventions. We have an action-packed agenda today, so to accomplish these objectives, our webinar sessions from this point forward will use this general format. I'll do about 10 minutes of research to ground us in some of the theory for each recommended practice. Then we'll have about 45 minutes to hear from the practitioners on what those recommended practices look like in action in Wisconsin schools. We'll close with a brief reflection and some sharing of resources, and then we'll be staying online until 10:15 to do any questions and answers for you via the chat box. It's important to note that even though the standards themselves have focus as a key element, it's hard to know where to start and where to focus when it comes to intervening. This leaves many of us in our schools and districts wondering, where do we go? What do we do next? That leads us to today's featured practice. Today's featured practice is going to focus on the discussion about interventions focusing intensely on in-depth treatment of whole numbers in grades K through 5 and on rational numbers in grades K through 8, in grades 4 through 8. The first session that we did was about ensuring that you first have a screening process in place for all students. The second webinar focused on mindsets. As we continue to move through the webinars, please remember that each webinar does build on the one before it. As we look at today and what content to intervene on in grades K through 12, it's imperative that you also build in opportunities for your students to see themselves as doers of math. As educators, we must support our students' sense of agency, authority, and identity. We want all of our students to see themselves as doers of mathematics. We want them to know that others believe that they too can be successful, and we want them to be able to identify themselves as a math person. So as we discuss content today, I want to urge you to think about all of our students in our buildings and what can be done to build their agency, authority, and identity. As we move in, let's talk a little bit about what's from the IES guide for those recommended practices. We are going to go a little bit more in depth about each of these 3 recommendations. The first recommendation is to establish collaborative teams with expertise in math instruction and curriculum to ensure that these 4 criteria are covered in depth within our interventions. First, we want to talk about collaboration. Collaboration among stakeholders is a critical piece in your culturally responsive multi-level system of support. Collaboration should occur at all levels and most definitely should occur when determining interventions for students. There are some critical components to mathematics interventions. We know we must integrate computation with problem solving. When we look at college and career readiness in Wisconsin, that is when our students have deep mathematical knowledge that they can later apply into problems and other contexts. Our students must be able to reason and make sense of calculations. We should have material that should ensure student growth, but what does that look like? We want to make sure that programs, practices, and/or techniques that we're using to intervene with our students are evidence and/or research-based. Students need ongoing and frequent practice of materials to deepen their mathematical understanding. But where do we start and how do we do this? This chart from Achieve the Core shows the progression of standards from kindergarten to grade 8. It's important to note that although this progression document goes to grade 8, please know that it's also applicable to our high school students. The goal of this is to show the progression of standards towards algebraic readiness, which we know that success in algebra is an indicator of post-secondary success. Secondly, the chart shows the main foci of each grade, and lastly, it shows the coherence and connectedness of the standards themselves. This chart could be a very useful tool to see how mathematical ideas progress through the years, as well as a way to back map particular standards students may be struggling with. As we look at the progression of standards, it's important to also know and make sure that as educators, both in our universal level of mathematics and in our interventions, that we develop and use strategies for learning basic facts before any expectation of knowing our facts from memory. Students should be able to develop and use strategies to compute with whole numbers, fractions, and decimals before the use of standard algorithms. We want to make sure that we're building conceptual understanding with our students first. When we talk about conceptual understanding, we're really referring to that integrated and functional grasp of mathematical ideas. Students with conceptual understanding know more than just isolated facts and methods. They understand why a mathematical idea is important and the kinds of contexts in which it's useful. They've organized their knowledge into a coherent whole, which enables them to learn new ideas by connecting to those ideas to which they already know. Students with deep conceptual understanding have better retention in mathematics. It's also important to note that when we talk about conceptual understanding, that we do that as we define strategies and algorithms. We know that in mathematics, students must be able to use efficient, flexible, and accurate strategies when working to solve mathematical problems. We also know that the use of strategies can also help students as they get later into algorithms. Within the content standards of the Common Core, they are very explicit about the use of strategies and algorithms. Within our standards, within our K-8 standards, there are 26 standards that reference the use of strategies. That's 11% of K-8 standards. When we move into the use of algorithms, please note that that's only in 5 of the standards, 2% of the K-8 standards, and we also don't see the word algorithm present itself in the standards until grade 3. Moving into the research, it's important to know that in grades K through 5, intervention should focus almost exclusively on properties of whole numbers and operations. We would like you to note that that can also benefit older students who may be significantly below level. The IES guide refers to number sense being a very important critical element of this. And number sense involves the ability to count meaningfully and also to understand the relationship among numbers. A student whose number sense is well developed can count a set of objects and state the total. The child can also represent the number or recognize the quantity when it's shown. They also know where that number occurs in a sequence. For example, they will know that the number 7 may be composed of a 5 and a 2, and that 6 is less than 7, and that 8 is greater than 7. Specific choices for the content of interventions will depend on the grade level and the proficiency of the student. But the focus for struggling students should be on whole numbers. For example, in kindergarten through grade 2, intervention materials would typically include significant attention to counting, an example would be counting up, number composition, and number decomposition. To be engaged with quantities greater than 10, it's imperative that students develop an understanding of place value in the base 10 system. Intervention should cover the meaning of addition, subtraction, multiplication, and division, including the knowledge of the properties of operations. One critical component in deep mathematical understanding is that we are intentional in developing conceptual understanding of mathematical concepts and ideas with our students. Intervention should also include materials to build fluent retrieval of basic arithmetic facts. Materials should extensively use and ask students to use visual representations of whole numbers, including both concrete and visual base 10 representations, as well as number paths and number lines, operations with whole numbers, and also we want our students to know that an equal sign represents equality as a relationship and not necessarily as an operation. In grades 4 through 8, intervention should focus on the in-depth coverage of rational numbers and advanced number arithmetic. Fractions present one of the greatest challenges for our students. NAEP test results from 2009 reveal that American students have consistently struggled with basic fraction concepts. Understanding fraction concepts is a prerequisite to meaningful computation of fractions, as fundamental for understanding decimals, percents, and ratios and proportions. Students must also understand how fractional parts are formed. Students need to first understand the unit and how fractions are labeled. The focus on rational numbers should include understanding the meaning of fractions, decimals, ratios, and percents by using visual representations, which could include placing fractions and decimals on number lines and solving problems with fractions, decimals, ratios, and percents. Students need to understand the relationship between a fraction, a percent, and a decimal. Students in grade 4 through 8 will also require additional work to build fluent retrieval of basic arithmetic facts. We'll be discussing fact fluency at the upcoming March webinar. And that will also require some additional work involving basic whole number topics, especially for our students who are showing significant needs. This next slide, I would like you to take a minute and stop and solve. I want you to think about, as you're solving this, how many 8th grade students have successfully, in the United States, have successfully solved this problem. We're going to give you 30 seconds to just take a minute to try to solve this problem. I know that was just a short time to begin to tackle that problem, but I'd like you to think about how many 8th grade students in the United States could successfully solve this problem. And actually, only 44% of United States 8th graders could successfully solve this problem. Ratios and proportions are an extension of rational numbers and are central to mathematical development during the middle school years. This topic exemplifies the kind of multiplicative thinking that is critical to further progress in more advanced mathematics. Understanding of ratios plays a fundamental role in the study of linear functions in algebra, particularly the concept of slope. The difficulties that students historically exhibit in learning rational numbers as well as ratios and proportions are evident. One reason that proportional reasoning is challenging is that it requires the analysis of quantities in order to identify underlying mathematical relationships. As students at this level and all levels within mathematics, they must understand the underlying structures of mathematical problems. We'll be hearing more about why and how educators in Wisconsin have focused their content in mathematics interventions. And coming up next, we're going to take these 3 recommended practices and look at what they look like in Wisconsin schools. Our key featured presenters today will be hearing from 3 different educators in the state. The first will be Karen Stitchen from Fall Creek School in Fall Creek, Wisconsin, in the northwestern part of our state, where she is a math interventionist and an RTI coordinator. Next, we'll hear from Marianne Modrock and Michelle Parks. Marianne Modrock is a math recovery specialist as well as a CISA 10 math coach, and Michelle Parks is a CISA 10 math consultant. So what we'll do now is we will turn it over to our 3 featured presenters.
All right. Hi, my name is Karen Stitchen, and I titled part of my presentation here, Where do I start with math intervention? This was my pressing question when I started 7 years ago. Just gotta wait, okay. So I've been a math interventionist or Title I math intervention teacher for 7 years at the Fall Creek School District. I teach grades K through 5, and I am passionate about math intervention. I started with nothing, no curricular resources, no manipulatives, no classroom. In fact, I had a whiteboard outside the music room in the hallway, and it was terrible for my students. But in my second year, I did get intervention curriculum. And in using it, I still felt like I had a problem. And I didn't know any other interventionists to connect with. I felt like I was alone in my island of math intervention. So I have a huge thanks to Michelle Parks, who's coming up here, because she will join us later. And she was a huge blessing in bouncing ideas off and helping me in this. My problem is I used assessments in my intervention curriculum resources, just as they said, along with the information from our universal screener. But something still seemed off. I couldn't put my finger on it. My students were making gains, and yet my students still seemed to have a missing piece in their foundation of whole numbers. I wasn't content just knowing that I had this missing piece, but why? And what was the missing piece? So as educators, we know decision making for instruction is guided by a good assessment. And for math intervention, that good assessment really can pinpoint our gaps in the mathematical understanding. My question for you is, what assessment do you use that identifies specific gaps? Does it pinpoint exactly where students are at? Or do you just have a general idea? So there's many pathways to develop mathematical understanding, and I'm not here to endorse a particular curriculum or resource, but one of my pathways to address this weakness of whole numbers is I had the opportunity to take Math Advantage training, or AVMR, from Math Recovery. Math Advantage, or AVMR, is a diagnostic assessment. It identifies student-specific gaps with whole numbers. But it taught me how children develop an understanding of whole numbers. It's not a curriculum. It is time-consuming to do, but the information is so valuable. I thought I had a fairly strong grasp in how children understood math. I even have 5 kids, and I was just so surprised at what I learned and what I took back to my classroom. I call it the building blocks of math. That is not AVMR's term. That's my term. And AVR, I learned, was the missing piece for my students. And I want to share how it changed my instruction, even using intervention curriculum. So when you look at these 5 building blocks in whole number understanding, there's actually 7 of them, but I'm going to focus on 5 for right now. The first is forward number word sequencing, and that is the ability to say numbers going forward automatically, and it's given in ranges. So if I have a student start from 57, and I stop the student counting or saying the sequence, not counting, to 64, can that student cross the decade of saying 57, 58, 59, 60? The other part of this building block is the number word after. And this is the ability to say the number after a given number automatically without counting. So if I ask what is the number right after 59, could a student say it's 60 without counting? I found that that number word after can be much lower than the student's sequence that they can say. The second building block is backward number word sequencing. This is the ability to say numbers going backward automatically, and this also is given in ranges. This ties heavily to subtraction. So if I had a student start from 103, say 102, 100, 99, can that student again cross a decade? Do they pause? Do they count to find the next number? The other part of this building block is the number word before. And this is the ability to say the number word before a given number automatically without counting again. So if I asked a student, what is the number before 80, could that student say 79 without counting? Now, I remember from my training that every time we forward number word sequence, we should be going backwards. And I felt, oh, that's an epic fail even as a parent, because I never thought of going backwards. I typically just said numbers forward with my students and my own children. So the third building block is numeral identification, and this is the ability to identify numbers automatically and given in ranges also. The fourth building block is structure. This is your ability to identify a small amount of objects and know how many there are without counting. So this is also known to teachers as composing and decomposing numbers. The structure truly builds the whole foundation of numerical concepts. I did not even see the importance, and I can't stress the importance of this building block. It's also the ability to recognize, for example, 3 objects instantly, and they could see 5 as 3 objects and 2 objects. The 5th building block is addition and subtraction strategies. This is a progression, and that is the progression that I seriously did not even understand until I took this. So we know we can see children that do not count 1 to 1. But then there's also the progression where they can count visible collections. They see 2 groups, but they can only combine the amounts if the items are visible. Then there's the screened collections, which is the students have 2 groups. You can cover them with a sheet of paper. Can they retain those numbers? Can they combine them in their head? And then the last part of this progression is later using bare numbers with strategies. So there are 2 more building blocks. As I said, that there's 7 building blocks. I'm focusing on 5. Marianne will focus on the 2 gray ones you see there, which is place value and multiplication division strategies. With these building blocks, I realized that students have missing pieces in these building blocks. And I have found that there isn't one intervention curriculum that is perfect. There never will be. So for me, no matter what the intervention curriculum is or resource, I don't isolate these skills and don't isolate them. Incorporate all of them into your skills in the classroom lessons and tie them together. The second point I have in doing this is teaching the number range a student can make sense of. So with students in their core, they're often expected to work to numbers at their grade level. So for example, to 1,000 or to 120. I don't match what they do in their classroom. This is not the purpose of intervention. This was a struggle for me when I first started, and that I had to help the students and the classroom teacher cover the content they're at. And I had to change that mindset that that is not my purpose in intervention. The third point I have is when I teach within the number range a student knows, and then I extend that concept to larger numbers once they understand the concept. When I decide what number range to work with a student, I consider both where they forward and backward sequence. But more importantly, I am really looking at what is their number word after and number word before range that they're also in. That's a critical piece to decide the range you're working in. Those tend to be far lower than the range of the same numbers, of the numbers that they can say in sequence. So for example, you could have a student that could forward sequence saying numbers to 80. They could say backwards from 30. But then when I ask them what is the number before or the number after, they might be in their teens. So for example, I want to give you an example of what extending number ranges looks like. So in the curriculum I use, there's a game called Pathways. And if you look on the left on that side, the typical game is the student rolls a cube with 10s and 1s. And their goal is to make a path to 100. And they also record those equations. But notice they're only addition equations. So I changed it also. I still did the one on the left, as you can say, God job, as it says, but not my writing. But on the right, there is the change that I made, and that is I had them subtract by 10s and 1s. And this was far harder. You wouldn't think if they could go forward, it should be as difficult to go backwards, and it is. So I changed that on the right, but then I extended it. And if you look, I have pathways to 200 now. But in this, I changed it not only to the number range to 200, but I had a die that had a 10, 20, 30, a 1, 2, and 3 on it. Once they were comfortable adding up with these numbers, then we subtracted back from 200 doing the same thing. Again, that was a big stretch for the students. On this particular screen, then we extended it once more, and this was an activity that along this whole pathways was done with third graders. So if you look, when the only concept taught in my intervention curriculum was sequencing forward 1 to 100. But I added going backwards from 100 to 1, going forwards 1 to 200, going backward 200 to 1, and then choosing one of their own. And incorporating, so my whole changes in this whole thing was incorporating multiples of 10, going backwards, and changing the progression ranges. The fourth point I have is don't move on until a student has mastered the building blocks in their number ranges. Otherwise, the gaps will remain. Even if you feel you are standing still for 2 to 3 months, you need to do so. I promise you it's worth the wait. Last year I had a second grade student who couldn't split teens. We sat on this concept. At the end of the year, she was trying to work to 100, and we were splitting up 100 and different components of forward and backward sequencing. And this year now, she's really going to 200. So you do see the change. It just takes a while for students at times. My fifth point is always use manipulatives, even for older grades, and visual representations before moving to the abstract. Use money, use place value blocks, 10 frames, number lines. Even for fourth and fifth graders, I am finding that we assume students don't need manipulatives, and we move on. But those struggling learners are visual learners, and we need to relate these concepts to the real world. It was like me asking the students, where do you see fractions in life? And they said everywhere. But then I asked them, where do you see them? And they couldn't tell me where they see fractions. So we take them away far, far too early. My seventh point is always continually look for the relationship and structure of numbers, regardless of the concepts I'm teaching. I feel my role is I'm the relationship builder. I have a saying in my classroom that the students know, and it's called use what you know. Most importantly, intervention is a process. You will continually define and refine in your practices and understanding. I've realized I'm never going to fully arrive. And incorporate each of these 5 building blocks into every concept you teach, regardless of your curriculum resource. I want to thank you for this opportunity, and now I'd like to introduce Marianne Modrak, who will expand more on whole number understanding.
Thanks, Karen. My name is Marianne Modrak. I'm a math coach at CISA 10, and my focus will be on math intervention with the concepts of place value, multiplication, and division. I'll be discussing math intervention in the areas of place value, multiplication, and division. All right. So generally, there are 3 main areas that I tend to focus on with any intervention work. These 3 consistent areas are language, and by language, I mean the student's understanding of words that we use on a daily basis, along with the use of correct, precise mathematical language. Concrete models, and these need to be concrete models that change so the students are flexible in their thinking. And I tend to focus on the student owning the learning. I believe that as long as I keep providing the correct experience for the student, that he or she will understand the concept eventually. For example, on why language is a focus area, is that I found at one school that when I asked students to tell me, when I asked first or second graders to give me 2 numbers that equal 17, they were telling me 1 and 7. When asked for a second way, they had no response. The problem was traced back to an experience that led to a misunderstanding. The experience was that students in the classroom were being led through a rhyme-type song about how 1 and 2 go together to make 12, and 1 and 3 go together to make 13, etc. This example leads to a main focal point in both preventing the need for intervention and an approach to intervention, that being the focal point of strong mathematical language being used by both the student and the teacher. For example, in the example just provided, if the song utilized the correct language of 110 and 7 ones, I doubt it would have led to the student's misunderstanding. And in fact, it may have provided an experience that they could build on. Interestingly, once the teacher was made aware of this issue, she stopped using the rhyme, and the trend of students responding to the question of tell me two numbers that equal 17 with a 1 and 7 response also stopped. Here is an example of a third grader's work that reflects the need of a student to own the learning. It seems that she has been exposed to the language of tens and ones and the need to add the tens and the ones together. However, she does not own this language or the concept, as she is taking the first add-in and then adding it to the digit in the tens place of the second add-in, along with the digit in the ones place of the second add-in to obtain her sum. In the second one, 67 plus 3 would be 70, plus 3 would be 73. This is one example of why, to prevent both the need for intervention and as an approach, strong mathematical language needs to be used by both the students and the teacher. This reminds me of a quote. I know that you believe you understand what you think I said, but I'm not sure you realize that what you heard is not what I meant. One of the best ways for teachers to realize whether a student has truly heard what was meant is for the student to be able to communicate with strong, precise language as they explain what is meant by a concept. Therefore, every student needs frequent opportunities to communicate their thinking. As I mentioned earlier, my first steps when providing intervention to a student or students is searching for the missing concepts that are creating issues, and generally the same issues arise. When it comes to working with place value, I target three main issues. I target the introduction of the language of digit and require its usage, the concrete building of quantities and identify the relationship of the quantity to the numerical representation, and a student's ability to explain. I find the introduction of the word digit and the meaning of digit to students, along with the required use of the word, to be a fundamental piece of place value understanding. When explained, the term digit eventually seems to make sense to students, and it eliminates confusion, a confusion that is created by the incorrect use of the word number to mean digit. With the knowledge of the word digit, students, starting in first grade, now have a grasp on why digits would need to have different meanings, which is created by its place in a number. Getting students to understand that these 10 digits are used to make an infinite amount of numbers seems to help their brain rationalize that each digit would have to have different meanings in order to make all those numbers. Students also need to discover the meaning of the name place value. This includes having students identify what the words place and value mean to have them followed by why the term place value makes sense. One way to help students familiarize themselves with the word digit, along with the words place and value, is to utilize the 100 chart to play a game. Both a chart numbered from 1 to 100 and a chart from 0 to 99 should be used in an alternating fashion, for example, every other week. The look of a student's face as they ponder why the number 100 is not on the 0 to 99 chart is priceless. Examples of some of the questions to ask students with these charts are: put an X on the 10 digits that are used in our base 10 number system, followed by how many numbers can be made with these 10 digits. Or put an X on the first 2-digit number, the first 3-digit number. Put an X on the first 2-digit number that is written using only 1 digit. Followed by the question, how are these digits different? Put an X on all the numbers that are made using only 1 digit. This activity, when administered with rich questions, can add to place value understanding. Another activity is the concrete building of quantities and the identification of the relationship of the quantity to the numerical representation, along with composing and decomposing numbers. The first step in this activity is simply having the student count out a various amount of counters. I generally start this activity focusing on the numbers 11, 22, and 33 because of the identical digits in both the ones and the tens. For example, I will have a student represent the quantity of 11. The student will then be asked to verbalize how many counters were counted, and the student will be asked to write the number 11. I then ask the student to identify where in the 11 counters is the 1 represented as I point to the 1 in the ones place. Often when asked to represent the 1 in the tens place, the student will identify just 1 counter. Because I want the student to own the learning, my subsequent questions or comments are meant to cause the student to ponder the decision to represent the 110 with one counter. I am okay if they are still baffled at the end of the session, as I know that I will come back to it until he or she can develop the understanding. Once the student has the understanding of 10 ones also being 110, we move to single sticks and bundles of 10 sticks. In the beginning, the student may continue to use single sticks. Eventually, with enough requests and a big enough number, the student decides to start using the bundles of 10. They are again asked to write the number and make connections between the material representation of the number and the symbolic representation. The questions or comments that I make generally fall along the lines of, how can that be, as far as why the 4 represents the 4 ones and the 4 represents the 4 tens. In this example here, when we get to 3-digit numbers, the student in this situation was asked to give me all the numbers that can be made with the 3 digits. It was amazing how easily she could find these 6 different numbers made with the 3 digits. However, I was then shocked at her ability to put these numbers in order, as far as least to greatest. This can be a huge struggle. So I brought in base 10 blocks and had the student build each one of the numbers. She still was confused until she was able to process the quantity that she built along with the numbers. She then eventually was able to make sense of this and stopped having any errors in choosing the least to the greatest. With multiplication, the missing concepts creating issues again tend to be a lack of language and a lack of experience with the concrete models representing a problem. Often when I ask students of all grade levels what the times symbol means, they will say multiplication or times. When asked to read a number sentence, such as 3 times 4, they will say 3 times 4, and they will not have any other way of reading this equation. I then ask students to close their eyes and picture the following: 4 times 3, 4 groups of 3. Their response is always the same. Basically, they say they can visualize the objects with the statement 4 groups of 3, but that when I say 4 times 3, they simply see the numerical representation. By expanding their language understanding of the meaning of multiplication symbol to include groups of, students begin to make huge leaps. Some students, however, are not quite ready to handle the multiplication equations abstractly. Therefore, they need to build a model for the equation. One easy way to do this is with a deck of cards. It's very important to have the student make changes to their model that represent additional multiplication facts so they can see how to use their knowledge base to help them with other facts. Students need opportunities to explain their thinking and to express the connections that they are making. This question will lead to a debate. The question, how can you use the knowledge that 20 times 15 is 300 to solve 21 times 15? Time after time when I bring this problem to a classroom, a huge debate develops between is the answer 301 or 315. However, once the students gain a knowledge of the times symbol meaning groups of, and they're able to discuss with each other their reasons for their answer, they're able to see that we're really talking about one more group of 15. With division, the missing concepts creating issues again tend to be a lack of language and a lack of experience with concrete models representing the problem, along with students owning their own learning. If the building blocks of place value and multiplication, along with the common issues addressed earlier, are taken care of, then the ability of students to divide becomes easier. If students have the language of multiplication having so many groups that are of a certain size, as opposed to multiplication just being facts, then students can understand that in division, they are either finding so many groups of a certain size, or they need to find how many of a certain size group there is. With the place value understanding and the ability to compose and decompose numbers with place value understanding, this will allow students to make sense of division. The concrete model that I like to work towards by the 6th grade when students are expected to learn the U.S. standard algorithm is the base 10 model. With the base 10 model pieces, students can represent each step of the U.S. algorithm with the pieces by trading hundreds for tens, tens for ones, etc. Needless to say, it is only with the student's ability to explain the process that they can own their own learning. These are some of the experiences that I try to provide students with when interviewing with students who lack an understanding about place value, multiplication, or division. Thank you very much for your time. And now I'll turn it over to Michelle Parks.
The focus for what I'm going to talk about is that focus on rational number. And I want to echo what both Karen and Marianne started with, in the fact that this is about getting kids to reason and make sense. And I think that's true along the way. I think when I work primarily with middle school and high school teachers, their concern around rational numbers is the fact that students try to apply an algorithm, or they try to apply some trick that they learned to answer questions without really having that sense making and understanding behind it. How do we foster number sense, and how do we continue to build that throughout all of the number systems is really the focus of this piece. And as Sarah said, this came out of the guide and the focus of today. And I wanted to bring us back to this because this is the piece about rational number. That focus on using visual representations in all of this work, and then having kids solve genuine problems, becomes really important in this work. Sarah mentioned some of the NAEP test results, and some of the research goes further back than that as well. And I don't think any one of us would argue that when we run into people on the street, many of them will say their least favorite part about mathematics may have been fractions. That's true in a lot of teachers' classrooms as well, that fractions are difficult to teach. Rational numbers in general are very difficult to understand, and there seems to be a gap in our knowledge base. The data that I've got reported on this slide goes back to 2007, and you can see that there were some issues with 8th graders and their ability to add those 3 decimal fractions and represent that as a sum. And then also that even our 8th graders at that time could not simply put those fractions in order from least to greatest. 2009, that data continued, and obviously from there we started thinking about, is there a better progression in understanding rational number? When you look at the fraction progression in the Common Core State Standards, you see that it actually starts with focusing on the meaning of fractions and equivalency, and that ability to compare and make sense, and that strong connection to the number line model in those diagrams. From there, we move into operation sense with fractions, and then we have that connection to decimals starting to happen. From here, obviously, when they get into the middle school level, they're starting that introduction to the idea of ratio and proportion and making all of those connections as well in the world of rational number. One of the things that in the research that we've been finding, however, builds on what Karen actually mentioned, and that we can't work on these things in isolation, even with our most struggling learners. We need to help kids make connections across standards, but also to the real world as well. This particular slide is showing that relationship that starts in 3rd grade, where we're starting to work with that number sense of fractions, but we're also connecting that to being able to partition shapes in geometry. I've had the great fortune for the last few years, along with Karen and Marianne, to work with a woman by the name of Cheryl Toby, and Cheryl Toby works currently for the EDC, and this work is actually linked at the top of this slide. And what they have developed is actually a site where the title of this is obviously Eliciting Mathematics Misconceptions. On this site, this is it will link you to several diagnostic assessments focused on rational number. You can see the topics here are fractions, decimals, and then operations with rational numbers. There are several different pieces of the puzzle. However, today, with the limited time, I'm going to simply focus on their first session that you see here, representing fractions 1. I wanted to draw this work to your attention because I do believe that part of what it is for intervention is truly identifying the right depth of understanding that kids have. Karen mentioned at the beginning of her session that starting with good assessment is obviously a focal point, and I know in your work in these webinars you've talked a lot, you're starting to talk a lot about what are those good assessments that we're using to identify diagnostically how to work with kids. When I spoke with Cheryl about this work, one of the pieces of the puzzle she told me was they actually have thousands and thousands of student data pieces from across the country, students that are struggling learners, but also students who are on track and are doing just fine in their classes. And they're finding that these kids have these misconceptions all across the board. There's some interesting data they're finding. did in their work is that as they looked at student work, they tried to identify what are the misconceptions that kids have. And specific to fraction and to rational number, this is one misconception that they see at this level. And as you can see, it's the idea that students will consistently associate the number of pieces shaded with the numerator and then associate the total number of pieces for the entire figure with the denominator, but they do not pay attention to the size of the piece. And so this is very typical, and I don't think there's very many people that would argue that this can be a concern. And again, that focal point with using visual representations, let's see how this next couple of slides demonstrates the depth of that we need to consider in our instruction. We obviously want kids to understand that the diagram you see on the left is a correct representation of the shading of the fractional pieces, and that the diagram you see on the right is an incorrect representation. That's this misconception of the size of the piece mattering that we have to look for. However, when we start thinking about instruction, we also want to think about the types of diagrams and visual models that we're showing kids to go to depth. These diagrams you can see compare the typical visual model that we might use, but we also want to make sure that kids see shapes that have parts that are equal area but different shapes. So they have to reason and make sense of that shaded piece in relationship to the whole, not just out of a number of pieces. Similarly, we have to also give visual models where the pieces are not grouped together, the parts are not grouped together. So they all, again, have to make sense of what does that mean in relationship to the whole. And finally, this idea that when we don't always have the partitioning clearly labeled, or it's different for different pieces, we have to infer what that fractional part means. This idea of the visual model is important, but limiting visual models to the same representation over time is very limiting to kids, and then they come up with a procedural response. For example, they will look and simply say, I've got X amount of pieces. In this case, I have 7 pieces, and 4 of them are shaded. So my answer is 4/7. That procedural thinking only goes so far. These other models of visual representation really allow for the child to go to more depth. In their work on that site, what they have on that site are pre-assessments and post-assessments. And the pre- and post-assessments are designed to get at these misconceptions. So here are 2 examples of that on that pre-assessment. The first one you saw in a similar diagram, and then the second one is asking if that's 3/5. As you can see, the whole idea here is, are they making sense of the size of the piece that's being shaded? Some of the student work then draws out whether or not the child has the misconception. Here's a demonstration of a child who said, yes, it's split into 4 different boxes and one of them is shaded, so it's 1/4. This child is clearly demonstrating the misconception. This particular example is an interesting example as the child is trying to reason and make sense of the pieces. The child is thinking, there's 2 of them, and I apologize for the diagram, it's a little dark, but there's 2 of them shaded and what appears to be about a half of another piece shaded of 4 pieces. So it's not 3/5. The child isn't fully complete in their thinking, but the demonstration of the understanding of the misconception is not there. The child is not fooled by the number of pieces shaded and is really making sense of the size of the pieces being shaded, which is truly the goal in looking at that assessment. Really, this is the tip of the iceberg for these assessments. If you go to this site, the ones that are in blue, you can get the full assessments downloaded. In speaking with Cheryl, they're in the process of updating the other pieces of the puzzle, but when you click on them, you will get a link that simply says, email me, and you will get all of those resources free as well. So please, I encourage you to dig into those. In 10 minutes of time that I had today, I obviously couldn't go into the depth of what was here, and I really wanted you to see that understanding of how deep we can assess students' thinking. When we get into the middle school and we start to shift that rational number thinking, there's a lot of things that happen in the world of ratio and proportional reasoning and those kinds of things. And there's so much to be covered that we can start to explore. A huge focus, however, is to continue to extend those understandings that kids have about rational number and to go even deeper with what it was they were experiencing in that 3 through 5. Again, there are some wonderful resources and supports that are starting to be out there, and I've seen some amazing things happen in classrooms with teachers. This quote actually shows how we need to bridge kids from arithmetic thinking to algebraic thinking, and the fact that we need to get kids to shift their focus from the numbers themselves to the reasoning about operations and those numbers. And I really think that's one of the things Sarah talked about at the very beginning. We have to focus on relationships and not just performing operations. We need to be intentional about conceptual understanding. We need to focus on reason and sense making and really deeply going into the meaning of all of these things. I think the years that I was in the classroom when we would have conversations with our high school teachers, as I was the middle school department chair, there was this stress that they had, and I couldn't quite put my finger on it. And many of them simply said they don't know their basic facts. But the more we've dug into the problem, it's not as much of an issue that they just can't remember some basic fact structures. It's the reasoning and sense making that those facts make sense in. A child who simply has no understanding of the operation when they even look at a problem is significantly more delayed than a child who can see the structure but maybe have forgotten some facts that they can't recall. One resource that we're working with in our area and trying to bring some support to is the work of the Transition to Algebra resources. And again, the link is here. What I like about the resource and the structures that I'm seeing is it's really about intervention and supporting the deep thinking of the underlying building blocks to get from arithmetic to algebraic thinking. So it completely builds on what Karen was talking about and building all, and Marianne as well, and building all of these things together to their next level. This problem is based on using Cuisenaire rods, and you can see the different shading, and Cuisenaire rods are obviously colored, and so you need to make sense and reason about these. But the design of this problem is to think about the structure of these representing different things and then reasoning about their relationship. So for instance, if you focus on column B, and we know that the rod on the top has a value of 6, we can start to reason and make sense of how the other pieces all fit together. And how do they relate to a value of 6? And can we determine the value of the other pieces and think about how they're related? There isn't one right way to do that. A child might see this piece here, this middle piece, and say, well, that's half of it, so that value must be 3. And then notice the ones on the bottom each have 3 that are connected to the value of that piece, so each of those must be 1. Another child may see that the top has a value of 6 as it is given, and then recognize there are 6 units on the bottom, so each of those are 1, and make connections from there. There's a wide variety, and the focus doesn't become on getting the answers and filling it in as much as it is how many different ways can you reason and make sense of those pictorial representations. I filled one column in and got thinking about how we might reason about some of these other pieces of the puzzle, and really getting kids to reason about those size and shapes become a very valuable exploration for children. Similarly, when we start thinking about the number line, while it is very important for kids to notice and be able to place things appropriately on the number line and make relationships and understand the different equivalencies of numbers on a number line, when we explore operation sense on a number line, we also get to a deeper understanding. So these structured problems also come from that resource that I spoke about, Transition to Algebra. And it talks about thinking about multiplication. When Marianne was referencing the language structure for multiplication, if I see this as 3/4 times some number h, that's different than thinking about 3/4 of h. And when children start to make that conceptual understanding of the operation, they can think about where that might be on the number line in relationship to that size on the number line. Similarly, they can do the same for 7/4 of h, or 7/4 of a group of h, and how all of that would fit in that visual representation. just being able to touch on some of those pieces of the puzzle today in 10 minutes is a difficult task. The world of rational number is very, very deep. And obviously at the middle school level, we want them thinking and exploring about ratios, proportions, and all the world of rational number. There's some wonderful resources out there, and we've shared some things with Sarah to have you continue to dig into them. One additional resource that I would recommend is the book Making Sense of Algebra. While it is about a focal point of getting kids to get to algebraic thinking, there's also those key components of rational number thinking that kids have to bridge that sense and to be ready for that algebraic thinking. There's some other really nice resources out there, and there's another book at the elementary level, going from arithmetic to algebraic thinking, that I might recommend, and I'll have Sarah put that on the list as well, that helps us think about at the elementary level, how do we really get kids into that number sense and the big idea of transferring to generalizable thinking and not just answer getting techniques. So we know this is the tip of the iceberg. We know that there's so much more for us to learn, and we're hoping that the little bits of information that we gave you today is enough to get you started on a journey with some resources to start thinking about and digging more in for your own professional learning. So we'll turn it back over to Sarah, and we thank you for your time today.
All right. Well, thank you, Michelle and Marianne and Karen. Thank you for sharing your stories and for taking those recommended practices and going deeper. What we'd like to do now is get you into just as we move forward into the presentation, just would like you to think about this question. To what extent does the content of the interventions in your school match the recommendations that were presented today? And you can enter those in the chat box, or this is just some food for thought, knowing that one of our outcomes is for you to be reflective and to use the content in these webinars to better impact the students in your own schools and districts. So thinking about that content that was presented today, what extent are you using those practices within your own interventions in your own schools and districts? For the sake of time, I think we are going to move forward. Just to let you know that there are additional resources. There's an additional resource handout with a couple of texts as well as a few of the websites that we did share today that will be available for all of you today, as well as once the webinar is posted to our website. What we'd like to do now is just open this up. Actually, before we get to opening it up for questions and answer, we do want to share with what's upcoming. So January 13th, we'll have our next webinar, which will focus on using visual representations within your interventions. So now what we'd like to do is open up some question and answer, and we'll leave that until 10:15. Please note that both my and Heidi's emails are at the bottom of the screen if you do have any specific questions, as well as Michelle, Marianne, and Karen's emails were all posted within the PowerPoint. If you do have any specific questions, they are still on the line if you want to chat them specifically, or if there's something that you want to follow up with any of them on, please feel free to do so.